Hey everyone, Scoop Scientist here. Now, have you ever wondered how fast magnets can attract each other? Well, so have I, so that's what I'm going to test today. I've got this and these types of magnets here, so I'm going to see if they attract each other at the same speed or at different speeds. So let's do it. Alright, so I've got this ruler here, that's what I'm going to be using for distance. And I've got my phone here, which I'm going to be using for the slow-mo, the high speed. And basically use the calculation speed equals distance over time and work out how fast the magnets are attracting each other. So I've got a couple of neodymium magnets here, and not sure what these ones are called, but these ones are not quite as strong as these. So my theory is these ones are going to be traveling a lot faster than these ones, but let's test that. I'm going to start off actually with the neodymium ones. And it's basically, I'm just going to hold this in place, level with a measurement here, and slowly push that in. And then I'm going to load it up. I'm going to then load it onto my computer and test to see, and go frame by frame and see when it starts. Get the distance, then go back to this, get the time, and hopefully get a measurement of speed. So let's do that right now. And I've also got this bag here. I'm using that just so it can reduce any friction that would have if I was to do it straight on the wood, so I can maybe get faster times and more accurate. Okay, so I've got that lined up with the 10 as best as I can. Now I'm just going to slowly start pushing that along till it gets attracted to the magnet. Okay, right there. I'm going to do that again because it just flipped up. It flipped up again, but hopefully I can work with that. So now I'm going to try to use the time as best as I can for that and see what distance that was. Alright, so I'm just using my compositing software to get frame by frame so I know where it started to attract, so I can get the distance measurement. Then I'll go to my regular video editing software to get an accurate time measurement. So it appears right on the 12, so I held the first magnet on the 10 centimeter mark, and it appears to start moving right on the 12, so like I'm talking exactly on the 12, so that means 2 centimeters. Well, that works out rather nicely actually, and you can see, bang, that's when it hits. So that's a very short period of time. So what I'm going to do is I'm going to trim it at 1.545. I'm going to trim it in, back. Okay, it starts moving at frame 1508. 1508. Bang. So there we go. Drag it back to the start, then I put a saver on it. Okay, and so I've just put it onto my editing software, and the full length for that is 1.07 seconds. So it was 37 frames in total for it to move the 2 centimeters, and it was 1.07 seconds. Okay, so if you look down there, those are my two things. So speed equals distance over time, which then means distance was, well, let's get these right. So if I want meters per second, I need to convert the 2 into meters. Actually no. I'm going to avoid all complications and just go centimeters per second. So I want to find out how many centimeters per second this magnet is moving. So that means I just go distance 2 divide 1.07. Alright. So that's pretty much going to be 2 centimeters per second, considering it's 1.07. Actually, only just realized that, but there we go. So that equals 1.87 centimeters per second. There you go. So that's how fast the neodymium magnets move. But now I want to go on to test these. I reckon they'll move slower, but let's see what the science and math says about that. Also, if you have any predictions, pause the video now, put them in the comments, write what you think, if these ones will go faster or these ones will go slower or even the same as the neodymium magnets. And then watch the rest of the video to actually find out if you were right. Okay, so same setup. I've got that one lined up on the 10 as best as possible, and then now all I've got to do is slowly push this and see. So it's on the 12 now, still hasn't attracted. Okay, I'm going to do that just once more, but I'll put that into my software to see. Alright, so now we've got that footage. Let's test how fast that attracted each other. Okay, so here we go. I'm going to see where it hits. I believe it hits right there. Frame 1, 3, 3, 5. So let's go 1, 3, 3, 5. Let's cut it there and now bring it back. So far, from what I'm seeing, it actually seems like these magnets are traveling faster. It could just be the fact that the distance is shorter and it's an illusion, but I'm about to find out. Oh, actually, no. So here's what I got for this one. So that was the speed of the neodymium magnets. So speed, just distance over time. The distance for this one was 1.5 centimeters, and the time, here we go, 1.05 seconds. So that is only just a quicker time, but it's I'll call it a significant difference in the actual distance that I had to travel. So let's try this. 1.5 divided 1.05 equals, yep, 1.43 centimeters per second. There we go. So the first one there, neodymium magnets, 1.87 centimeters per second. But these other magnets, 1.43 centimeters per second. So as I said at the start of the video, my prediction was these ones would travel slower, and as you can see from here, the results that I got, it actually did travel slower. So I'm very happy with my results there. I'm glad that I actually got that right. And those were actually the only types of magnets that I had, so I would have liked to have tested more. And now there's actually a couple of things that I forgot to mention. I just figured this out after I finished filming, but the first thing was that the speed that I got of the magnets was actually only an average, because the magnet it starts off slow but then accelerates faster, so that speed's only an average. And because I filmed it in slow motion, I filmed it 4 times slower than real time, so I need to actually multiply each one by 4. So for the neodymium magnets, it was 1.87 centimeters per second, so I need to times that by 4. So the actual speed of that, or the average speed, was 7.48 centimeters per second. So that's quite significantly faster than what I had. And now for the other one, was 1.43 centimeters per second, so that times 4, 5.72 centimeters per second. So I just wanted to clear that up. If you did enjoy that video, please give it a big thumbs up and don't forget to subscribe to see future videos like this.